Hi, team. Welcome to a frigid Math Friday. The weather outside is frightful, but Delta Math is delightful. And I'm going to take you through a walkthrough of all of these different topics. Before I do, I'm going to pause the video and I'm going to complete this assignment to 100%. And I'll show you. I don't want to do this as a flex. It is in part a bit of a flex, but it's also me wanting to just show you the level and show you. How when you are solid with this material, how quickly you'll be able to get this kind of work done. You want to develop this speed because it's going to help you do more work and change the world in bigger ways when you can do more with your time. So here's the time there. It's 10:01. I'm just going to pause the video, and when I come back, this should all be completed. Okay, there we go. 100% done. Took me 13 minutes. 13 minutes to finish that work. So that is to say, if you're finding that the work is taking you a very long time, I don't want you to spend a very long time. 1 hour of your day would be a lot of practice. And then if you're finding that you are able to get it done quite quickly, very good. What it's showing you, if it takes you a long time, is that you need more practice. I have had more practice than any of you because I'm 42 years old and I do math for a living. You are not that old and you don't spend as much time on math. So, anyway, let's go through some of these topics and we'll learn how to solve all these problem types. You see, I had to make a few notes myself. So, you want some paper with you for some scratch work, and that's going to help you go through these problems. I'm going to start with the most challenging ones first, which are these ones, which we haven't taken a lot of look at yet, but we do have the mathematical tools to work with scientific notation down here. So adding and subtracting in scientific notation, let's take a look at that. Actually, I'm sorry. We're going to go from the top and go down because that's going to make it the easiest to navigate the video for your benefit. So here we go. When we're working with greatest common factor here, this one is a time trial, and you want to find the greatest common factor between 28 and 35. Factor trees can be very helpful here. I'll change the timer so that you can have a lot of time to do these. 28 is divisible by 2 and 14, which is 2 and 7. 35 is 5 is divisible by 5 and 7. There is our greatest common factor, 7. So I click 7. Okay, next one, 50 and 34. Well, I'll tell you right now, it's 2. Okay, you'll start to spot them very quickly. 34 is divisible by 2 and 17. 17's prime, so we're done. 50 is divisible by 2 and 25. 25 is not divisible by 17, so 2 is the greatest factor. 44 and 50. They're both just 2. 2 is the answer again because 50 shakes out into a 2. 44 has no factors 5, so 2 is it. 6 and 20. 2. Okay, so you just put in the best one. 24 and 6. Well, 24 is divisible by 6. Watch. 24 breaks down into 2 and 12, which is 2 and 6. I found the biggest factor there because that won't have any factors bigger than that. So can't have a factor bigger than yourself. 49 and 26. 49 is 7 times 7. So 7 is not a factor of 26. The biggest factor is 1. Okay, so this is how we do these. Okay, so we're just going to stop. And then I'm not going to beat my best time of 12 seconds there, so whatever. Yeah, so let's keep going. Simplifying fractions. Simplifying fractions we will do with our factor trees as well. But you don't have to if you don't want to. You might say, well, 25 over 100. Well, I know that 25 is 1/4, like 25 cents, and there's 100 cents in a dollar, and there's 4 quarters in a dollar. So this is 1/4. Okay? There's lots of ways to do it. Factor trees is a very powerful way that will always work. Okay, simplify the following one. 24 over 80. Okay, I see that they're both divisible by 4, even 8. They're both divisible by 8. So maybe I do my factor tree and I skip some steps. 24 is 3 times 8. 80 is 10 times 8. So I can write 24 over 80 as 3 times 8 over 10 times 8. 8 cancels 8, and we have our answer 3 over 10. Okay, so that is like sometimes you just see it and and you just write it in, and Delta Math gives you 2 chances to get it right. So feel free to make some mistakes. There we go, 3 over 10. Boom! And then we get a check mark, okay? This is their method. They did the full factorization breakdown. They did a full factorization breakdown, the common factors. They find the greatest common factor. My method, I think, is a little cleaner, where I find new ways to write those two numbers and do that. They write it this way, and they say, I'm going to divide both those numbers by 8, and I happen to know by some kind of magic trick that that's going to work. Mine feels less like magic to me, so I know that you can reproduce it if you're good at factor trees. Okay, let's look at one more example. Next problem. Simplify 50 over, so, well, that's 2 over 3. You see, I just see it right away. Why do I see it? I see that they're both divisible by a quarter. Okay, it would take 2 quarters to make 50 cents. It would take 3 quarters to make 75 cents. So I remove the factor 25 and instantly have my answer, 2/3. It's very, very fast when you do a lot of practice with this. And that's going to make you more mathematically literate in a lot of situations when you can do this type of work in your head and not rely on a calculator. Okay, let's keep going. Okay, convert improper fractions and mixed numbers visually. Okay, here. So these types of questions ask you to change these types of fractions, like 4 and 6/7, into an improper fraction. I like improper fractions. I don't like proper fractions. I don't like these mixed numbers. Yuck. So 4 and 6/7. So this is the way I convert those. Well, you can see here, 4 and 6/7. Here's my 6/7. Here's my 1, 2, 3, 4. There's 7 in each one of these. So I can count this way. I can go, there's 7/7 in each one of these. So I can go 7, 14, 21, 28, 29, 30, 31, 32, 33, 34. And I can get my answer 34 over 7. Okay, but maybe you don't want to do that. Maybe you want to use algebra. So it would go like this: 4 and 6/7 is equal to 4 times 7 plus 6 over 7. Why did I do that? Okay, you take this number, because 4 is equal to 4 times 7 over 7. 7 over 7 is another way of saying 1. Okay, so 4 is equal to 28 over 7. Okay, so since that's 28 over 7, I can add 6 to it, and that's going to make 34. So that's how I did that. Okay, I can do it by counting over there, and I can do it by some algebra. That's my answer. Watch it be incorrect. No, it's very much correct. I'm very 100% on that one. Let's do one more. Convert this to an improper fraction. So I do 3 times 6 plus 5. 3 times 6 is 18, plus 5 is 23. So this would be 23. Go away, big keyboard. Go away. This is 23/6. And let's talk about that another way. I can count by 6 here because there's 6/6 inside each whole number here. So this is 6, 12, 18, 19, 20, 21, 22, 23. I'm right 6 ways from Sunday, so I know that's right. Okay. Now there's other types in here. Convert 9/5 into a mixed number. This is asking you to write 9/5 as a mixed number, and this is a very useful skill, especially if you want to put weird big fractions on number lines and know like how they compare to different integers. So 9/5. I want to take out my biggest factor 5 there. Okay, so the biggest factor 5 I can take out is 5. I can't take out 10. I can only take out 5 from 9. So this is equal to 5 plus 4 over 5. But 5 over 5 is just 1. So this is 1 and 4/5. That's my answer. So I put that in here. 1 tab 4 tab 5. Submit answer. Enter. Yay! And how many groups of 5 are in 9? They tell you here. They say 1 and 5, and there's a remainder 4. They do lots of stuff. You can look at their stuff, and if you can see what they're doing with the numbers, you will see they use equal signs in the same way I do. You want to use equal signs the way I do. The way I use equal signs is I only write things that are equal to each other on opposite sides of an equal sign. I'm a little bit even superstitious about that. I don't want to violate the sanctity of an equal sign. Okay, let's keep going. So now we're going to go down to evaluating expressions. This is a new skill, and what it asks you to do is some substitution. Okay, so here it gives you expressions like this: 3z's minus w. And you can think of this as like, what's the price of a zebra and what's the price of a walrus? Okay, zebras cost 3 and walruses cost 3. If I want to buy 3 zebras, but I'm going to give back 1 walrus, how much do I have to pay the store? Okay, so I can use those types of things. Here's how I would use my paper to work through these. I copy down this first: 3z minus w. Okay, and I know z is equal to 3 and w is equal to 3. So let's put them into the equation. Always substitute into brackets. 3 bracket 3 minus 3. Okay, so this is equal to 3 times 3 is 9 minus 3 equals 6. And if you can do that in your head instantly, then you can just write in the answer, 6. But if you want to use paper, this is how you would do it. Let's take a look at how Delta Math does it. They say 3z minus w. They start from what's given. They take these and they substitute them in. Notice they substitute into brackets. This indicates multiplications. If 1 zebra costs 3, 3 zebras would cost 9. And if you want to say zebras, well, that's between you and your dictionary. Okay, I say zebra because I'm a bit posh. All right, next one. 5z squared minus z minus 4. Well, this is just, it's 14. But let's show you how to work that out, okay? So you write it down. Same. 5, and here a z is a zebra now only costs 2. Okay, that's the thing with letters, is we can change what they equal. So this is z. I don't like using z. I'm going to put a little cross through it so you know that's a letter. So 5z squared minus z minus 4. Okay, well, that's equal to 5, substitute into brackets, 2 squared minus 2 minus 4. That's a 2. Okay. And now what's 2 squared? Okay, here. 5 times 2 squared. What order do I do that in? Do I do multiplication first or exponents first? Let's see. They say PEMDAS on here, but we say BEDMAS. Brackets, exponents, multiplication, division. Division, multiplication in any order. Addition, subtraction in any order. Exponents came first. Let's do the exponent first. 5 times 2 squared. 2 squared is 5 times 4. Okay, I do this one first. Minus 2 minus 4. Okay, now let's do the multiplication. 20 minus 2 minus 4. This is equal to 20 minus 2 is 18, minus 4 is 14. Okay, 14. Hey! Okay, so they did the same thing that I did because that's the correct way to do it. All right. Boop, 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 boop. I didn't do it exactly the same way in my head, but I know my head method works as well. I'm not going to teach you my head method. You can build your own that allows you to do it quickly. Now let's evaluate some expressions with some exponents. Okay. So here you do it in bedmas order. Sorry. So let's first, what we do is we write it down. Okay, or you do it in your head. Let me do this in my head. Oh, this is a difference of squares. So that's pretty cool. Is it going to be? It's going to be 1 times. Sorry, just a little distracted. 1 times 9. It's going to be 9 on top. Yeah, it's 9 on top divided by 9. This is 1. This is equal to 1. Okay, so here, this is how you do it. 5 squared minus 16 on top divided by 3 squared. Okay, well, this is equal to, and I'm going to use an equal sign in the correct way. I'm going to write the same thing over here, just different. 25 minus 16 over 3 squared is 9. Okay, I did the exponents inside the brackets first, and I did this first. I still have to work out this exponent first, 25 minus 16. Well, 25 minus 16 happens to be 9, and it's being divided by 9. 9 divided by 9 is, hey, where are you? There you are. 1. Enter, enter. Yay! They say PEMDAS, which is fine. You can say PEMDAS just the same way I say zebra. PEMDAS is a little bit more posh than BEDMAS, but hey, I got to keep it real, okay? And they do it the same way I do it. Evaluate the exponent first. Work out the brackets first. Do that first. Now the expression of the parenthesis has been evaluated. We start again. Boop, 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 boop. Okay, they're really writing down a lot of steps. I don't think you need that many steps. Okay, let's keep going, everyone. So now we're going to do our basic exponent rules. I'm going to do a separate lesson on this in just a moment, but I'm going to show you how you can work this out just by writing your exponents as multiplications. Okay, you already have the tools to figure this out. I'm going to do the figuring out for you because, hey, it's a snow day and we can't be a perfect math class. 3 to the 8 divided by 3 to the 3. Well, we have been subtracting exponents when we have fractions like this, and we can do that as well. This is 3 to the 5, and that's totally correct. But I'll show you why. Come on, man. Work. 5. Okay, but now here, watch. 3 to the 8 over 3 to the 3 is equal to, notice I'm going to write the same thing on the other side, just different. 3 times 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 3. Did I do that right? There's 4, there's 4. Yes, that's 3 to the 8. 3 times itself 8 times over 3 times 3 times 3. And now I start canceling. That, cancels, cancels this, and this cancels this, and this is what I'm left with. 3 times itself 5 times. So this is also equal to 3 to the 8 minus 3. Okay, 3 to the exponent 8 minus 3. 8 minus 3 is 3 to the 5. Yay! That's the final answer. Submit answer. Yay! And make sure, don't forget to say yay, and don't forget to pat yourself on the back for doing a good job. I felt pretty cool when I was able to finish all this Delta Math in 13 minutes for you. I'm also fond of the number 13. Okay, so that's a base. Oh, we'll do more basic exponent rules. So this one is 3 to the 4. Okay. Yay. Okay, I just used the same rule. I did 8 minus 4. They'll show you both methods. Expand it, cancel what can cancel, and then what you're left with is what you're left with. Or subtract the exponents. You'll notice if you can figure out subtract the exponents, it saves a lot of steps. 3 to the 8 minus 4 is 3 to the 4. Okay, let's find another one. Next problem. Geez. Okay. Because I'm in as a student and I'm not in as a teacher, I can't just cycle until I get a new one. Oh, this is 3 to the 2. Okay. Yes. Okay, this one here. Now, when we're multiplying, we don't subtract the exponents, we add the exponents. So let's take a look. Okay. 5 to the 5 times 5 to the 6 is equal to, I'm going to write the same thing. 5 times 5 times 5 times 5 times 5. That's 5 to the 5 times 5 times 5 times 5 times 5 times 5 times 5. Okay, I think that was 5 to the 6, right? 1, 2, 3, 4, 5, 6. My writing leaves a little bit to desire, but let's count them. Okay, you already realized that, we could have done that a lot easier if we just added the exponents. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5 plus 6 is 11. But this is really cool. We can say that this is 5 to the 5 plus 6, and we can save ourselves a lot of time. This is 5 to the 11. Why did I write down 10? I don't have a undo button in this program either, which would also save me some time. 5 to the 11. 5 to the, go away, big keyboard. 11. And Delta Math was hanging for me, but there, and this is the last problem type that I wanted to take a look at. Great, thank you, Delta Math, for finally giving me this problem type. Notice I asked you to do a lot of these. Yes, I want you to get a lot of practice with this, and we're going to be practicing this Tuesday, Wednesday to get ready for our test Thursday. Exponent laws. We've discovered this through scientific notation, I hope. So here, 6 to the 3 to the 5. All right, let's work from the outside in first, okay? I want to take this bracket and multiply it by itself 5 times. So I'm only going to write what's equal to this on the other side. So this would be 6 to the 3 times 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 6 to the 3. Okay, that's 6 to the 3 to the 5 expanded. Notice I didn't let this fool me. I just did what that told me to do, okay? What I see students doing is they say, oh, there must be different now that I've never seen this before. No, just do what you've done before and you will be correct. And then I saw from before, when I'm multiplying, and here this is just multiplying, but several times I add the exponents. So 3 plus, so this would be equal to 6 to the 3 plus 3 plus 3 plus 3 plus 3. Add the exponents together. So that's equal to 6 to the 15. Notice that 15 and 3 and 5, this is also equal to 6 to the 3 times 5. When we raise a power to a power, we multiply the exponents. And if you forget that, you can always prove it to yourself by writing it out as a multiplication. This is to the 15. Go away, big keyboard. Okay, there, that's how you do these. That's how you do all of those. Okay, so that's basic exponent rules. Then we got add, subtract, and scientific notation. You've seen that before. I'll show it to you again because I'm this friendly guy who shows you things many times over. Okay, so here, to do this, I can say, well, there's actually a trick here, but I would just recommend expanding this out unless you can figure out the trick yourself. Okay, if you can figure out the trick yourself, then that's great. 2, 6, 7. Okay, that's this number without the decimal, and I'm going to move the decimal place once, twice, 3, 4, 5, 6, 7. Okay, so I have to add zeros. 1, 1, 1, 1, 1. Okay, so that's that number there. Subtract this number here, 2, 1, 9. I know that it's going to line up that way because it's raised to the same power. I'm sure Delta Math will give me one where it's not raised to the same power. Don't you worry. Okay. So now I subtract these. I work from this side. These are all, when I do my subtractions, these are all zeros. 7 minus 9, I can't do that. So I'm going to borrow one from there. That's now a 5. And I now have 17 here. 17 plus 50 is 67. So that's why we do this borrowing here, to do this subtraction. 17 minus 9 is 8. 5 minus 1 is 4. 2 minus 2 is 0. So I now have this number, 4, 8 with 5 zeros. So now to put that back in scientific notation, I'm going to go 1, 2, 3, 4, 5, 6. So this is 4.8 times 10 to the 6. Let's recap. I feel like I went a little fast there. First, I expand the numbers out, and then I do my subtraction. I could use this tool. I didn't when I was doing my Delta Math in 13 minutes, except for a couple of the dividing questions where I don't want to do that longhand. So you write out your numbers, you do your subtraction, and then you have to put it back in scientific notation. So it's actually really great practice for all of our scientific notation. When I get my result, which was 4,800,000, and then I move the decimal place, I figure out how many times I move it, and that's the power of 10 that I need to do that. Okay, somebody answer. Yes. Hooray! Let's do one more with a different. Okay, show an example. Yeah. Okay, so let's take. I don't want to do them all and to get to different examples that show you different things. Okay, so here, this is a nice one. See, this is a question where they gave you one number in standard notation and one number in scientific notation. In order to do this, you have to expand that number, and then you'll find that actually they have the same number of significant digits. And so when you subtract, you're going to get, this 6 million, and then put that back in scientific notation. Okay? You just have to do it. I know many of you are very good. You arrived at high school good at scientific notation already. So multiplying and dividing scientific notation things was a new thing that we were doing to discover our exponent laws. Greater versus times greater. Okay, these are interesting problems. The size of a cell is... Huh? Well, what's it not showing me? Huh? The size... What? The size of a cell is typically found by capturing an image under a microscope, then using software to measure its diameter. 2 cells are measured using this method. Okay, I've never seen Delta Math do this where there's a problem there that's not even there. Congratulations. Oh, it's because, weird. Okay. Strange. Okay, anyway. Okay, so here, cell G is this big and cell H is that big. Okay, how much larger is the diameter of cell G than the diameter of cell H? How much larger? So When they're saying much, they want a measurement. Okay, they don't want to know how many times larger. They want to know, like, if I measure this one, it's 2, and that one is 5, so it's 3 bigger. Okay, but if you want to know how many times bigger is 5 than 2, well, it would be 5 over 2. You would use division to find out how many times. The clue there is the word times, which connects to our times tables and multiplication. Okay, so let's do this question. All right, so I want to know cell G. They say how much larger is cell G than cell H? Oh, all right, cell G. Yeah, cell G is the bigger one. Okay, so let's convert our numbers into from scientific notation to standard notation. So we have. I'm just gonna copy it here. Boop. And I have magical paper where I can copy things in this way. Boop. Boop. I can't copy in this program. Okay, well, live and learn. All right, copy it out, Mr. Jennings. 4.52 times 10 to the negative 2. This is a set of instructions that says divide by 10 twice. For those of you who have figured out what a negative exponent is, congratulations. It's also a set of exponents saying move the decimal place this way twice. Okay, so I will have this number, 0.0452. I'm going to write that out over here so it's cleaner. 0.452. Notice I don't have the greatest handwriting, but I keep my work nicely organized. 5.45 times 10 to the negative 3. Okay, that's a set of instructions saying divide by 10 3 times. 1, 2, 3. So I have a 0 there, 0 there. And for clarity, I add this 0 before the decimal place. So I will have 0.00545. Okay, so these are the sizes of the cells. They're that many centimeters big. Okay, the cell in your body is going to be very, very small. You can see infinity in the grain of sand, okay, and eternity in an hour. So that's why we need scientific notation for these types of things. So now I just do my subtraction, okay? Notice I lined up the decimal places. That's very important when you do your subtraction. Mr. Jennings, can I just do this on a calculator? Yes. Okay, here. But I do it by hand, and my math is darn good. Okay? I just noticed I need to borrow all the way from over here. Okay, look. 0, I can't take 5 away from 0. I can't borrow from there because then my 4. So I'm going to borrow from over here. And actually, so what I do is I borrow here. And this is a 1, and that's 10, so this is 5. 1 I need to borrow here, so that's 1, and that's now 4. And so this is now 11 because I borrowed a 10 from here. So 10 plus 1 is 11. 11 minus 4 is 7. 4, I can't do it, so I borrow 1 from there. This is now a 3, and this is 14. 14 minus 5 is 9. 3 minus 0 is 3. This is 0, 0 is 0.0001. So there. And now I need to move the decimal place this way. So that tells me I will have 3.975 times 10 to the move the decimal place twice, negative 2. There's my answer. So I'm going to give my answer in scientific notation because I'm a boss. And it's going to be 3.975 times 10 to the negative 2. And if I get this wrong, I might go out and make a snow angel in the snow. Okay, I might need that much refreshment. Hooray! Hooray! I did not make any mistakes. All right, so that's how you do those. The next problem. How much greater? Okay, blah, blah, blah. Okay, I want to just see some examples. The approximate populations of these two places. Okay, New Mexico is bigger than Wyoming. Even though that number is bigger, we know that the exponent makes a bigger difference to the size of the number. Okay, so New Mexico is bigger than Wyoming. How many times greater was the population of New Mexico than Wyoming? Now we have to do division because we want to know by what factor is Wyoming smaller than New Mexico, or is New Mexico bigger than Wyoming? So they're going to divide New Mexico by Wyoming. See, they put that number on top and that number on the bottom. They separate out their powers 10. I like that. That's fine. They do this division. They get that ugly decimal. They do that division. They get 10 to the 1. They use subtract the exponents. Good for you, Delta Math. And then they multiply that by that, and they get 3.6. They round, okay? Oh, here's another thing. Write your answer in standard notation, rounding to the nearest tenth. So standard notation means don't give it to me in scientific notation. Rounding to the nearest tenth. Okay, so this is the ones column. This is the tenths. The hundredths are here. The second decimal place is the hundredths. This decimal place, this is the thousandths, the 10,000ths, the 100,000ths. Okay? Tenths, hundreds, thousandths, 10,000ths, 100,000ths. Okay? So that's where your decimal places are. Okay? So when they say round to the nearest blah, you have to find that to the nearest one. This is a 2, so it rounds down. If it's a 5 or greater, it makes the next number round up. You just add 1 to that number. And that's rounding. Okay? We'll get lots of practice with that. And if you're making mistakes with your rounding, look at the Delta Math examples and it will help you. There's a few things in here you got to figure out yourself. Okay, mixed word problems in scientific notation. These are fun. Oh, it's going to do this thing again where it says, congratulations. Oh, thank you, Delta Math. Okay, the approximate areas of Virginia and Delaware are listed. What's the difference between the areas of the two states? Okay, we already looked at that. This is subtracting these numbers. Okay, so you're going to find the difference. We would have a positive difference. So you'll take the bigger one, which is Virginia, and you're going to subtract the smaller one, which is Delaware. Okay. Now, another thing you can do to add on to your learning here is you can go ahead and you can go get Google Maps, and you can say, go in Google Maps, and you can say Virginia, USA, and we're going to compare the size of Virginia. Oop, and I want to zoom out. So there's Virginia. Cool, looks fairly big. Then I want to compare that to Delaware. Where's Delaware? What are we looking at? Where's Delaware? United States. Small mid-Atlantic United States. Sits on a peninsula. Okay, so this must be Delaware. They're not even showing me the name of Delaware. I don't know my U.S. geography. What are you kidding? But I wanted to learn something new today, people. I didn't learn anything new from the Delta Math, so I'm learning something new here. Delmar. Okay, whatever. Anyway, I see that Virginia is bigger. Okay, that didn't. Oh, there it is. There's Delaware. Look, it's little and it's small and it's half of that peninsula. That's super strange. There's Virginia. Look how big. There's Delaware. Look how small. Okay, and then we see how much bigger is that. Is saying if I subtract this area from this, how big will it be? That's a really complicated math question unless someone's already measured it for you. This is not just length times width, people. Finding the area of that is pretty complex, especially when you consider it's not even flat, it's stretched around a circle. Whoa! So, anyway, that's our Delta Math walkthrough for today. If you've stuck with me this long, wow, I appreciate you showing up for your learning. And I also thank you for hanging with me because I get a little bit sarcastic sometimes when I do this math. It's fun for me. It's fun for me to make a joke out of it. So I hope that it was fun for you to practice your Delta Math today and to build your math muscles. And if you're hanging with me still, send me an email with the code word Sasquatch. Okay. If you send me the email with the code word Sasquatch, I will send you back a big high five and probably have a prize for you on Tuesday. Bye for now, everyone.